Great. Well, welcome to Codingscape. This is our AI practice that we have monthly, where we talk about topics like the 𝗼𝘆𝗶 platform or projects we're delivering on for our clients, and share knowledge. And we're super stoked to have y'all here as guest speakers, and appreciate the material you provided beforehand. So Dr. Zhang, I'm happy to turn it over to you, and we'll have some questions for you at the end. And Reyna and Dr. Zhang, if you have any questions for us about anything, we're happy to answer that as well. Get the conversation going afterwards.
Sounds
good,
good.
everybody.
Yeah,
All
thank
right,
you
and
for
I'm recording this.
Sure.
Take it
Please
away.
feel free to stop me during the talk. You don't have to hold your questions till the end. So let me
Often we'll put questions in the chat, and so if there's like a good kind of pause, if you want to every now and then pause, and I'll read off some of the questions that are in the chat and we can answer them from there. Sound good?
Sounds good. Yeah.
Okay.
Can everyone see my screen and hear me fine?
Yes.
Yep.
Cool. Hello, everyone. I'm Yiying Zhang, associate professor at UCSD. So today I'll be talking about a unified generative AI workflow platform that we built, or is still building, called GenseeAI. Minimize this. As we know, there are a bunch of different foundational models that are getting more and more capable these days, like 𝗟𝗏𝗄, Gemini, GPT-o1, 𝗵𝗆𝗺𝗏, llama, and many other generative AI models. And they're fueling different sectors like finance, healthcare, manufacturing, retail, IT, CRM, many different parts of daily lives. So when we are talking about generative AI, and especially in the 2B setup, what we see that how Gen AI is deployed in production is usually not just a single model, but more like as a workflow, a task flow. So these are user-defined workflows consisting of LLMs, other models, tools, function calling, various data sources, or even human in the loop. So to just give you a quick example, so let's say a company wants to develop a customized QA interface. So this would be their end user asking a question, and then they will have probably like LLM agent to construct a query that goes into both their internal data sources and a tool that calls to retrieve relevant web pages. And afterwards, these retrieved information will then go through another potentially LLM agent to summarize the content, and then to generate an answer to the end user. So you can see that even for these simple tasks, it already involves a type of workflow or task flow. So today, how these workflows are developed are usually initially an engineer programmer need to construct and write programs or use a GUI to construct such workflow. And afterwards, they need to tune each step, like tune the prompts, set up, choose the right model for each step. And then after deployment, what we've heard from certain businesses that when anything goes wrong with the answer, for example, they will need to manually go and figure out, oh, does the error coming from the construct query or like data source or summarization? So there are a lot of manual effort, both at constructing time, deployment time, and runtime. And because this process is now done manually, the generation quality is still subpar, and because of a lot of other issues in the models like hallucination. So what we see is there's a huge room for the final answer on generation quality, and especially because like different people are deploying, writing these programs differently. So there's inconsistency in the generation quality also. Another subtle problem is that it may not be as much a problem today, But what be a bigger problem tomorrow, in the future, is that now you're using a bunch of smaller steps to now accomplish a more complex task. So in this process, if you are just like blankly choosing, let's say, the largest model, or if you're executing on a traditional LLM-based serving system, what we are seeing is 10x up to 100x cost bloat. And at the same time, because today's infrastructure designed for single model serving, so the performance, application performance in terms of latency, throughput is also not ideal. So all these issues are because today's AI infrastructure are not built for generative AI workflows. And traditional ML infrastructures are not built for generative AI. So there are like workflow infrastructure, there are ML infrastructure, there's a Gen AI infrastructure, but no like generative AI workflow infrastructure. So that's where we come in. We're building the first generative AI workflow platform to offer fully automated deployment with high generation quality, low cost, and fast speed. So this is how we are attacking the problem by offering different layers, full stack of solutions, both at deployment time and serving time. So at deployment time, what users send, like programmers they send, is a workflow that they write in different formats. It can be like written in LangChain, it can be written in DSpy, or potentially even like written with a GUI. And then they would also specify an evaluator to say the generation quality, which one is better. And that would go to our workflow optimizer. And what optimizer leverages is a hub, or you can think of it as a registry of various optimization techniques, and also model hub, and potentially also evaluator hub. So we are collectively calling this a workflow tuning hub. And these options go into the optimizer, and I'll talk more about how we actually do the optimization. And the product of the optimizer is intermediate representation that is an optimized workflow. So this finishes the deployment time. And at this part of the from the optimizer, we can already see at deployment time, we can already see up to 56% better quality and up to 9x lower cost, monetary cost. And then these optimized workflows get stored in some workflow storage. And then at runtime, when a user request comes for this workflow, you can think of it as like a serverless function. And we now retrieve the optimized workflow from the storage, and then we apply a further online optimizer. Afterwards, it can go to different backends. It can call closed source models, APIs, cloud APIs, your own serving system, or it can call our generative AI workflow native serving system. And if you're using our serving system, then it gives you additional 2x lower cost and 10x improvement in performance, depending on the workloads. I'll probably pause here for a bit.
What kind of optimization processes are going on here? So I see that there's like, we have this workflow process step, and then, seemingly, model, like separate sort of model inference steps that are optimized separately. So I'm a little curious on, what techniques are being used for workflow optimization. Is it, simply trying to, cache data where it would be more effective and reorder orders of operation? And with the ML optimization, is it, compiling these to different inference platforms and that sort of thing? Don't know if that was too much at once.
I will go into the details next.
Okay.
Yeah. Any other question about the overall flow? Okay, so I will then just go talk about the technical details of this optimizer. So our optimizer consists of two parts. One is the core part, which is called Cognify. You can think of it as a compiler that takes front-end inputs that's returning like long chain dSpy, potential volume, or llama index, or just directly written on top of PyTorch. And they can also be written on top of our programming model. And then, like I said, user also specifies a evaluator and optionally a cost and performance SLO. And then I think I skipped. Yeah, and then the Cognify will utilize this workflow tuning hub that I talk about to generate the optimized workflow as an intermediate implementation that goes to different backends. So what it does, it improves workflow structure, automatically selects models, selects different optimization options, and what it achieves is better generation quality and lower cost. So let's go into details of how Cognify works. So how it works is by using a stage workflow hyperparameter tuning. So what this means is if you look at this workflow, which now we are turning the original user deployed program into internal graph structure. So if you look at this internal graph structure, it is almost like a layered deep neural network model. And traditionally, to tune a deep neural network or a complex model, you would perform various hyperparameter tuning. So here, if you consider this whole workflow as a model and different options as hyperparameters, so what we are choosing here is basically a hyperparameter tuning problem. And what Cognify does is it first solves the graph structure problem by automatically selecting optimization that could potentially change the graph structure. And then afterwards, within the given structure, it chooses further optimization options within the structure, for example, auto model selection. And then if this satisfies the user specified criteria, it will stop. Otherwise, it will go back to stage one. And if it stops, it will generate this intermediate representation that can run in different backends. Okay, so how are stage one and stage two actually perform? Like I said, we model this whole process as hyperparameter tuning. And traditionally, hyperparameter tuning are performed with a Bayesian optimization framework. So we are also using Bayesian optimization frameworks here. But the key difference is now hyperparameters becomes different optimizations, different models. So for stage one, the possible hyperparameters are the ones that we store in this optimization hub, and this can be a public hub or a private hub. And we support things like prompt decomposition, multi-step reasoning, this graph structure reordering. And users can also specify their customized prompt templates, or they can say we want to cache previously used prompt templates. And in the future, we'll also support rag tuning and tool substitution. So all these optimizations go into the Bayesian optimization process. And the Bayesian optimization process will try to, with our customization, will find a way to quickly find an optimized plan based on the user-given evaluator that is built on top of the evaluator hub. So what it does is basically will try out and execute different combinations of these optimizations in a quickly descending way. And every time when it does a trial, it will use the evaluator to say if the generation is better or worse. And after this phase, we move to the stage two phase of auto model selection. So these will now Cognify works as a model hub that stores different open source models, closed source models, user fine-tuned models, and with a similar Bayesian optimization process. Now stage two figures out the right models to achieve quality and cost goals. Any questions about this?
That's a lot to absorb and is really cool.
Okay, so maybe I'll just give some examples next. So the first example that I'll show is a RAG QA that we take directly from LangChain. So this is a bit involved RAG-based QA. So the question is first goes through a query translator that translates the question, natural language question, into something that can be constructed as a query. And then it will also go through some routing phase to say which prompt to use, and then it will construct query based on the backend database. And then the database has different indices, different formats. And after retrieval, the retrieved documents get summarized, refined, ranked by this retrieval agent. And afterwards, it will measure, oh, if this satisfies the user criteria. If not, it will go back to basically retrieve again and then generate the final answer. So this is the simplified original LangChain program, largely simplified original LangChain program. So the first step, the 0 step we do is to port this into our internal graph representation. Again, this is a simplified graph representation. What you can see is there's like a decision point here, and afterwards it's retrieval, doc filtering, knowledge curation, also composing the answer, verify the answer. If it's not good, then go back to the decision again. So stage 1 tries to optimize the graph structure. So for example, this is a key step. So we automatically figure out, oh, this is a key step that is critical to the generation quality. To get better quality, we separate that into several sub-steps. And then you can also see certain steps we're running parallel because we feel, oh, from the analysis, there's no dependency. So we can run them in parallel to improve performance. And there are also places that we move, reorder and move to the earlier stage. For example, this original verification step, it was done at the end. But then if the initial selection is not good, you go through all these other steps for nothing, and then eventually the verification will say no, and then you go back. So you waste a bunch of cost and performance. So what Cognify automatically figures out is this step can be partly moved to the initial phase, and the initial phase would say, oh, if this task decomposition is not good, it goes directly back instead of going through all this and then say no. And all these are automated. And then stage 2 within this given graph, this demo is just choosing between GPT-4o and GPT-4o mini. And the blue circles here is the vector database, and red is what Cognify automatically figures out these steps are critical to the final generation quality, while the green ones are not as critical, and we can use GPT-4o mini to save cost. And finally, we generate an output. And this is just one example of generation. So what Cognify actually generates is a Pareto frontier. So you can choose either best quality, regardless of cost. You can say, I want like 99% quality, but given that, I want the best performance, lowest cost. So that's why there's a range. So for this example, we are achieving 5.9x to 9x cost saving and 0% to 7% quality improvement compared to the original program executing with just GPT-4o. And the compilation itself takes only 50 cents. And compared to an exhaustive grid search, this is 13 times faster and cheaper. So the second example is more complex. So this is a data visualization task where a user gives a natural language task specification for generating a scientific figure like this. So what the original program does is it has an agent to expand the query, and then a code agent to generate the code to for generating the scientific figure, and then a visual agent to judge if this figure meets the user criteria, both on the scientific side and on the styling. And then it will generate feedback that goes back to a code debugging agent to do self-debugging and generate code again until the circle, until you meet the user-specified criteria. So what we do, this is the 0 step. We still part it into an internal graph representation. So this is a simplified version of the graph. So you can see now we have loops here and more involved multi-agent system. So structure 1, again, is graph level optimization. So you can see some part of this. Now we are decomposing that. And here we also decomposing the task. And stage 2 is applying different optimizations. So I'm not showing other optimizations that we're applying here. So including adding automatically adding few-shot examples, multi-step reasoning. But just showing here is choosing between 2 different models. So I'm giving you 3 data points of the generation. So that can achieve 25% quality improvement with 6% less cost, or 56% quality improvement with 48% more cost, or 99% of quality retained. So basically 1% quality loss, but 76% less cost. Again, compared to original program using just GPT-4o, and compilation itself is only 80 cents and 64 times faster and cheaper than grid search. Any questions?
What are the input? What are the inputs to like the Bayesian model? Is it just like target cost and like some resource utilization things and then it uses that for like the optimization target, or is there a little bit more to it there?
Yeah, so that's a good question. So the input first is the program itself, and then it's the hub, and then I think it's not here. Then it's the user criteria of like whether I want all the data points that are on the Pareto frontier line, or I want like the best quality given this cost constraint, or I want the lowest cost given this quality constraint. So usually it's either one of those, right? I want like best quality given this cost constraint, or I want lowest cost with this quality constraint.
That's really cool. And it just does like there's just Bayesian inference over and over to try to get as close to that. That's very cool.
Yeah, of course, there's a lot of like detailed technology goes into this Bayesian optimization flow to make it run faster, cheaper, and achieve a good getting to the Pareto frontier.
Very cool.
Okay, so that is the optimizer and deployment time framework. I will very quickly go over our serving side. So the serving side, what we target is a multi-tenant environment, and our goals include efficient GPU resource utilization, better application throughput, and lower latency, and also reliability and observability. So this involves a distributed workflow scheduler that operates at the global level and at per GPU level. And then this workflow scheduler supports auto scaling, load balancing, and part of the transformer-based generative AI model as its intermediate state. So we also have a system that manages distributed state across generation and within the same generation. And like I said, it has multi-tenant support, resource isolation, SRO attainment for different SROs, and monitoring and failure handling. Some of these we're still building. So I just give 2 features, talk a little bit about 2 features of the whole serving side, which are published. So the first one is called Intercept. So this was published at this year's ICML. What it does, it handles LLM-centric workflow by allowing an LLM to be efficiently intercepted by other entities. And other entities can be tools, can be other models, can be human, can be rack system. So when this other entity interrupts the LLM generation, what we need to do is to manage the state that the LLM has already generated. So if we just like always discard this state, upon the return of these finishing of these other entities, we now need to recompute everything. So that is obviously not always efficient. So what InfoSep does is adaptively choosing the strategies for dealing with intermediate state and to improve each of these strategies. And the end result is 1.6x to 10x performance improvement in terms of serving speed over VLM. And another feature we offer is distributed management of state. And here, this system called 𝗶𝗺𝗲𝗆 is targeting long and shared context. So this happens when you're, let's say, you're asking multiple questions to the same long document, asking questions about a video, or you have a long series of steps that follows the previous step, creating a long and shared context. So what we do here is we have a global distributed serving system to co-design context sharing and load balancing. So basically manage both state and computation with a two-level approach. I will skip all the details, and this 𝗶𝗺𝗆 system optimizes average and P99 per request latency of up to 14.5x for the average and 10x for the P99 compared to SGLAN, which is another SOTA serving system. So this is our rough timeline. So we have we are close to finishing the optimizer. There's still some loose end to tie, and we will try to support. It already supports long chain, but we'll try to support more front ends with our preview version in October, and then we'll offer a preview version of our optimizer plus serving side around December timeframe. And then after that, we'll start building the SaaS and a basic SaaS offering early next year, and then have more paid features later next year, like customized optimizer, customized hub, multi-tenancy support, monitoring guardrails, other enterprise features. So that is it. Any questions?
Oh, that was great. Thank you so much. My question is, yeah, so October preview in October, but when can we start playing with it and evaluating it?
Are you interested in evaluating the optimizer or also the serving system?
I think both. We definitely, I think there's a lot here that is really interesting that we would love to start understanding and seeing how we could use it and giving feedback.
Depending on your what front end you our optimizer, the core optimizer should be ready in a couple of weeks. We're actually targeting a paper deadline, ICR deadline, LR deadline in a couple of weeks. So that should be the time when the core of the optimizer is ready. Depending on the front end, if it is written in Longchain or DSpy, that will be easier and quicker for us to support. If it's written in other programming model, it may take a little bit more time. But still, I think in the October framework.
We use quite a few different frameworks here. We've used LangChain before. A lot of it is various PyTorch based stuff though. But if it was available with LangChain, I'm sure there would be something that we would be able to do with it.
Sure. Yeah. So Reyna here can answer more questions about connecting to the front end. And then in terms of serving system, I think the initial version we should be able to preview in December. Yeah, basically this.
Great.
Yeah, this is a very neat solution. Kind of splitting out different tasks to different models based on an optimization model. I think that's just fascinating.
Cool.
Yeah, I'm kind of picturing this, and Zach and Jenny here and Kenner who just left probably have the best understanding. But what I'm picturing is especially like all the workflows that are being created with drag and drop GUIs right now. It's and even with code, like we're not creating the optimal workflows. Like we're creating the kind of base case logical workflows for solving the problems that we're trying to solve. But if it makes sense if you're able to turn those into a graph or parse a LangChain application or workflow into a graph, then yeah, absolutely. As long as you have the inputs into it, you can start parsing it. And Zach, you kind of asked my question. I was wondering about was like the pricing and performance that goes into like the calculating the Bayesian probability that an optimization is going to result in either cheaper
Right.
execution or better performance or better quality, etc.
Right.
Yeah. So in practice, how do you envision, like, let's say we've got a client with a LangChain workflow. In practice, how do you see like us using the GenseeAI platform to create like an optimization and then serve it?
So it depends on if the time frame here. So for this year, before we have the SaaS offering, it will basically just like running our compiler as like just run like a single command line compiler to compile your program at deployment time. And then afterwards, at serving time, it will be self-hosting. Like you would need to set up your cluster like in the cloud or locally, and then run our distributed serving system. And then when our SaaS is ready, it will just be, you basically just run it on the SaaS, and then deploy the workflow like you are deploying serverless computing now today. Like you are deploying your function as a service, and then afterward, when and you define what are the user triggering events, and then when that happens, we'll just serve that in an auto-scaled way. So the SaaS would model the serverless computing's fast framework usage model.
Yeah, that makes sense. Is the output of the optimizer an executable or code that needs to be built into an application?
So it is because it is a workflow, so it has like executable like program execution. If the workflow consists of a program, and it can be just a closed-source API calling, model calling, or cloud API. If the workflow has that, yeah. So, but it will just be like automatically executed the whole workflow. But internally, it can involve code execution, RAG retrieval, model calling.
Okay.
That, yeah, makes
so
sense.
is the output of the optimizer step human readable?
Yes. But currently, we haven't visualized that, so it is still as a program, but it is with our internal representation.
And that's in Python?
Yeah, yes.
Cool. That's really exciting. Any other questions?
It's not a question. It's just an observation on your branding. How did you land on GenseeAI?
It's GenseeAI, and basically our university and where we live is on Genesee Avenue, and we don't want to like be exactly the same as the avenue name, and it has a Gen in it, so it is Gen and C.
Yes. So smart.
Reyna and Yiying, do you have any questions for us?
So yeah, and probably this will need another session for, and potentially maybe even like NDA signing, for us to see some real examples of your workflows. And I'm also curious about your evaluators. How do you determine lead generation quality for your workflows?
Yeah, great questions. Happy to share some of our work. I can get an NDA sent over there for you to take a look at. Yeah, the evaluation is definitely interesting. I think a lot of that is still more qualitative than quantitative, because of the end result being a user that's interfacing with an application using an LLM. You know, there's some kind of baseline evaluation that we run everything through, like, is this a dangerous response? Is this is the LM returning something that is going to be harmful? But beyond that, I don't think we've really been looking at performance or cost as part of the evaluation, because everything is still pretty subsidized by the LLM hosting providers themselves. Zach, you might have a better answer to that than me.
Yeah, we have some eval stuff that we've done in the past, but a lot of probably the vast majority of things have been done with purely qualitative evaluations. But like in 𝗏𝗺𝗃, we did a little bit of quantitative measuring and things like that.
Oh yeah, I can send you the 𝗏𝗺𝗃 project. That was I can't remember if I mentioned it before, but that's the project where we took Llama 1.4 and fine-tuned it in order to add capability to produce code in a library that it previously did not have that capability to produce code.
Okay. And just like, I think I'm interested to know like how you are thinking you potentially would use our solutions. Like is it more for like your experimental, for internal use, of potentially also for production? And are you more interested in the optimizer part, like quality improvement or cost reduction, or both?
I think definitely the optimizer for improving quality. I think you are a little bit ahead of the curve on reducing cost of inference of serving, but the rest of the industry is going to catch up to that here soon. I think reducing costs, I saw OpenAI floated the idea they might charge $2,000 a month per license for the new Strawberry reasoning model when they release it, because I think we all know that OpenAI and everybody are not charging enough money to cover like their actual computing costs. And so at some point they'll do like what Walmart did, which is, every time they open a store, they have low prices. And then when all the competitors are gone, they raise their prices. And so having techniques and tools for lowering the cost of serving is definitely going to be something that our clients are looking for and would be happy to have. I think we're ahead of that, but knowing how to do it, like getting ahead of that question, that conversation, I think is fantastic. And so that's one of the things that has me excited about this as well.
Cool.
Reyna, what do you got? What questions you got for us?
I have one question about like the framework usage of your clients. So you said like you've used LangChain, 𝗏𝗏𝗼𝗆. Are there any others?
We've used a few things. A lot of our internal stuff is just like in PyTorch, especially when we're like doing model development. But in We've used a variety of other front-end frameworks, either for client demand or just for exploration purposes, so we understand the playing field. SGLang, Llama Index, we've used most of them probably.
Okay.
But I think a lot of recent stuff has been set up through Vellum for any client-facing stuff as of late.
Okay, is that a like programmable interface, or is it just like
Not
a drag
really.
and drop? Got it.
Well, there's like some,
Okay.
I mean, Jamie might be able to speak better to this, but yeah, it's largely like GUI setup, like node-based graphs, some API functionalities in there as well, though.
And can you access like the individual nodes in that graph through code?
I'm not sure. I can't really speak to that
Okay.
level of detail there.
You kind of build the workflow and then execute the workflow, but you can, modify each part of the workflow and deploy it. You can be like dragging your document index, pointed at your prompt, pointed at like a text transformer if you want to like transform data, and then redirect it to the output, and then you just call that.
Are you sort of getting at if that could be used as like a front end for the
Yeah, I'm kind
IR?
of curious if like I know like your clients would prefer to do the drag and drop, but is there a way we can like query
Yeah.
some Vellum endpoint to like modify like the prompt or modify that graph?
We're in pretty close
That's a-
communications with the team, so I wonder if it's
Okay.
just something that we could ask Jimmy. Maybe if we could
Yeah.
just
I'm baking
float it
down
and
here.
float it over there. Because when you mentioned that, I kind of felt like you're hinting towards that too, which would be
Yeah,
very
yeah.
cool if they support that.
If it's pure GUI, I think it potentially is still doable. Definitely takes more time to basically have a way to translate that into a program format.
Right. I mean, I'm sure it's like in
Optimize
some XML format, but there's a lot of context missing if it's just, whatever makes the visual layout and the ID that this is this node, but separate from
Right.
implementation.
Right.
Yeah, they don't use LangChain. It's their own bespoke setup.
Mhm.
Just in the text chat.
Yeah, great question. I just fired that over to them. So when we get a response, I'll let y'all know.
Cool.
Great. Yeah, Cody, I had a question for you, and since I see you in chat. I know Bobby and Rob demoed 𝗏𝗀𝗆 last time around. Do you know what framework they used on 𝗏𝗆𝗆?
Not off the top of my head, no.
Okay. All right, I'll find out that too. Cool. Well, thank you so much for your time.
Thank you.
Reyna and Yiying. And yeah, look forward to getting to see the preview in October, and we'll be in touch. Pablo and Ali and Zach and I will be in touch before then with some more demos and more conversation.
Sounds good. Yeah.
All right. Thanks, everybody.
Absolute pleasure. Thanks, everyone.
Thank you.
Yeah, thank you, everyone.